Forging cyber security experts. Secure Ninja.
Hey everyone, I'm Alicia Webb with SecureNinjaTV. Now, our free preview of SecureNinja's online Sensei series has generated such a positive reaction that we've decided to give away every single module from this Cyber Kung Fu course featuring Larry Greenblatt, Tom Updegrove, and me. If you like what you see and would like to experience a Secure Ninja training course in person at any of our training locations, we have some amazing time-sensitive specials for you. Just visit SecureNinja.com/specials for all of the do not miss deals. And now, here is your free module from Cyber Kung Fu for the Certified Ethical Hacker version 8. Enjoy!
Alicia, let's recap where we are. So earlier, we had pointed out that, well, first we want to know the people who work at the target company. We're looking for the machines they run. We'd like to know what operating system they may have, Microsoft or Linux. And we're looking at what applications they would run and maybe what type of mail server or whichever that would help us understand the targets and the, our attack plan. Well, we did it initially through passive reconnaissance. We were doing things like who is lookups, and maybe if you were looking for a job engine, we're looking for somebody who understands Microsoft NT or Microsoft 2000. Well, obviously you have Microsoft 2000 in there, right? But now we're going to get a little more active. So we're going to actually have to send some probes to these machines and determine what they do. And again, we want to know the operating system and what applications are listening. If we can, we'd even like to say, well, if it's an application as a web server, whose web server would it be? Is it Microsoft's? Is it Apache or something like that? Well, to really understand how this works, let's take a step back and understand how computers really evolved. So we want to find live hosts. That could be a little rough there, I'm sorry. We want to find live hosts. These are powered up machines. Finding the listening ports. So this means if I'm listening on port 80, for example, I'm very likely a web server. If I'm listening on port 25, I'm very likely an email server. And again, 53 likely DNS. And a CEH candidate will have to know a number of more ports besides these, but these are very, very common. And again, if I know these ports are listening, that just tells me what app's loaded, but what operating system? Is it Linux? Is it Microsoft? Is it Mac? And then finally, what might these be vulnerable to? So it's kind of like a martial arts scenario. I want to know, I look at the guy, how big is he? Does he look like he's better with his hands, his feet? Is he more of a grappler? Is he more of a striker? And what school did he come from? Is it more of like a hard school or a soft school? And knowing these things about them, what might they be vulnerable to? So what is it? What does it do? And what are some of the problems or things I might be able to exploit? Okay, so if we just go over the evolution of computers, originally we had a computer. Some scientist shows it off, look, this thing can do something faster than any human can do. But then somebody else wants to use it. So they have to separate something in the computer that lets it know who's using it, not just can you add these numbers. So the computer has a new component. And then there might be other things to do. So besides adding math numbers together, we may also want to have a database. We have email. All right, so now the computer has to understand there are multiple applications, there are multiple users, and I have to differentiate what user is in what application. Kind of like at the hotel, what person is checked into what room. But now we have multiple computers and they're sharing information. So now we've gone from one computer, one user, one application to billions of computers, billions of users, and billions of applications, and we share this information over the internet. Well, we have to address them. So we have addresses for users, could be your username, but how do I address an application and a computer? Well, the Department of Defense has come up with a standard for that in their TCPIP protocol suite. Let's take a look at how that worked. So again, we originally had Bob working on a computer, and the computer now we know has an operating system, and the part of the operating system that actually mediates who's using the computer and what applications inside is known as the kernel. And we've decided to give these kernels, excuse me, it's an A, IP addresses to separate one computer from another. For the applications, we have port numbers. So for example, if you see port 80, the application someone is communicating to, very likely web. I say likely because you can't always trust what people say. So the Department of Defense created TCPIP with Al Gore. No, I'm sorry, I'm just teasing. I think Al got a bad overall deal on that, by the way. First book I ever read on the internet was actually 1990, and it was introduced by Al Gore. And I think when he ran for president, people were like, "What do you know about the internet?" And he was like, "My middle name, internet, bitch." And then they like checked at the hospital. No, his middle name's not internet. He's a liar. But whatever. Okay, so I'm not going to pick on that too much. All right, so they decided to give a couple of different addresses, and we're going to focus on these addresses up here. So let's not worry about later on the sniffing module. We're going to get these lower level addresses. But right now, it's safe to say that a computer can create data when a user uses an application. But to get that data to somebody else, we're going to worry today about two addresses that get added to it. So just as I were to send you a letter, Alicia, if I want to mail you, and I'll put you in a nice little dress here, a letter to get to your computer, I would need to know, well, tell the mailman, to Alicia from Larry. Well, originally they called this the host-to-host layer, but we're going to call this the transport now. Transport. They added in to Alicia from Larry and what's called a segment header, and it's not really Alicia, it's to port 80, say, from port whatever, and your host port, by the way, will always be something high, and we're going to talk a little bit more about that later. But if I talk to a server and they're a web server, I'll say destination port 80, source port probably something higher than 50,000. We'll get much more detail there later. All right, and then to let you know, or to Alicia, what mailman could pick that up and deliver to Alicia? Larry, could you give me your house? So I give it the internet layer. Originally this was called the internet. We're going to call it the network today. At the network layer, in a packet header. In a packet header, I say the destination, source and destination IP address. And now I can communicate. I can create what's sometimes called a circuit. And this is often called the circuit level. Later on, we talk about firewalls. We'll talk about circuit level gateways versus application layer firewalls. Just to give you a quick heads up, I might have an access control list that says, you may talk to this IP address because that's my firewall, or that's my web server. And you may talk to this port number because port 80 is. But people can lie about things, and you look closer and you go, that is not HTTP there. Now here's an issue. How do I really know what's there? I can listen to you. I can get opinions from people. Well, in a later module, we're going to work with sniffers. And we're going to go in great detail about how sniffers can read this information and see it. But for me, I like to introduce it early. I've been sniffing ever since, well, they came out. Pretty much Sniffer came out for me in about 1990. It's a very expensive tool, but now you can get freeware Wireshark, and I highly recommend it, and every good hacker looks at it. So we're going to take a look at the information in these headers, and then determine what operating system are you likely running, what applications are likely there. Once I know what you have, there's the Common Vulnerability and Exposure database, and we'll take a quick look at that, maintained by MITRE, and I always get there via the National Vulnerability Database, and see, once I know, oh, this is Microsoft Windows 2007, Service Pack 1, what is that vulnerable to? All right, so let's take a look at how this kind of works. So again, the TCPIP model was created by the Department of Defense in the late 80s. And I learned about this in '89. I was an IBM certified advanced connectivity specialist. And we learned that TCPIP is dead. That's right, it's going away. It's being replaced by the OSI 7-layer model. And in case you missed it, the OSI 7-layer model actually died. Most people do not realize that. In fact, the OSI actually, or the ISO, dropped support for this in '94. But since people kept using it as a teaching tool, it's kind of made its way back. In 2010, they wrote some more that bring it back, but the ISO wants $200 and some for every document, so I don't necessarily buy their stuff. But if we get a little more granular and take a look at it, what did they do? Application, say as word. How will I present the letter A in a series of ones and zeros? And that's a challenge. And actually, I avoided the movie Titanic because it was a chick flick. There's no lasers, there's no space scenes, there's no robots. I don't know why anybody will watch this. But eventually I got to watch it, and I obsessed over it. And one of the big problems was that we didn't have a presentation layer standard to represent things in a digital format. And we did have electronic communications. We had the telegraph. The Radio Act of 1912 was a direct response to that and said, look, we have to standardize, and they picked Morse code. And that's why we standardized Morse code. So it's very important that we agree on how to present things. Later on, we're going to see how hackers change that presentation to avoid detection. But we'll worry about that later. All right, the session layer is when you realize, okay, I'm going to use Microsoft Word, and I'm going to save it as a doc file. I'll present it that way, and I'll save it on my F drive, but I don't have an F drive locally. Where's the F drive? Oh, that's on that NFS server over there. Well, how do I get onto that server? The session layer is when you realize it's not just you in the world. So when I think of it as a human, I travel to different countries, and there's certain protocols you learn to say whatever hi. You learn the magic words first. You generally learn please and thank you. You learn how to at least log in. You learn how to log out, right? You learn how to print, and these are session layer standards. But what we're mostly focused on right now is the transport and the network layer, and we're going to look at particularly transport layer has TCP and UDP as its transport protocols that we mostly think about, and at the network layer we think a lot about IP, and we're going to look very closely at those addresses. Later on, when we do our sniffing module, we'll pay more attention to the data link and physical layer, but that's not important right now. All right, so using Wireshark, the world's most popular packet sniffer, and again, we're going to have a whole section on this, but I can see these things, and we have a saying in the Wireshark community, you can have opinions of users, you can have opinions of the developer or whatever. Show me the packets. Packets don't lie. Just on a side note, I think the reason the 7-layer model survived as long as it did, it's a very natural thing for humans. We say 7 colors on the rainbow, but there's not. It's a continuous band. Humans categorize things in 7s. Also, I think that when they developed this, you know what was going on. You know, listen to the stones around or whatever, and I think they're doing yoga, but I'll save that for another talk. Maybe at Black Hat someday I'll relate to the 7 chakras, and it's kind of neat. They both do start at physical layers. That's kind of awesome. But much more to the point to any CISSP candidate is to know the difference between TCPIP or TCP and UDP as transport protocols. Why would an application use one versus the other? Well, it's kind of like why would you use FedEx versus the US Post Office? TCP has 3 services that UDP doesn't provide. TCP provides flow control. So if somebody's talking a little too fast, you can tell them, slow down, dude. It's reliable. If it doesn't understand what you said, it will ask you, I'm sorry, I did not get that. Please say that again. And it's connection-oriented. And this is a very important thing for any CEH candidate. Any connection-oriented protocol, let me go to the board here, is going to go through 3 basic phases, and just think of a phone call. Phone calls do this. A, you send somebody some way to connect to set up the session. You call them up, whatever. It's we're going to call this connection establishment. You dial them up. Connection, that's an I, establishment. And they may use different words. We could say session setup. Some way, hello, this is Larry. Hey, Larry. Okay. And then you're going to tell them what you were going to tell them. B, data transfer. This is the reason I called. And then you have a graceful termination process. So it's nice when people just don't hang up on the phone on you. They said, yes, I got what you're saying. Okay, I love you, bye, bye. And you have some type of session termination, connection. Since I use connection establishment, I'm just going to change words. And I'll say session teardown, but recognize the concept, not an exact word. All right, now for TCP, much like a phone call, there's a very testable, very vulnerable 3-way handshake. So a system wants to talk to some server. And the first thing he does, and we're going to look at Wireshark, very detailed at what this happens here, but basically we say they send him a SYN. That means synchronize with me. It's like, the server will say, synchronize with me. And I heard you. So SYN-ACK, I heard you. I acknowledge that you said synchronize with me. And then finally they will acknowledge your request, and I heard you too, ACK. So they'll ACK your SYN, and that's the 3-way handshake. Hello, this is Larry. Hey, Larry, sorry. What if somebody calls you up on the phone, and you go, hello, but they don't complete that? That's three-way handshake. I would probably go, because you know, some people might not realize. My mom, it could be hello, 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 and then I hang up. But for that moment, I can't get another call. Well, actually I can. I've got a call waiting. I can get one other call. Suppose they just keep doing that. Eventually, I can't take a call. A very common, very testable denial of service attack is to overwhelm people with SYNs, and it's known as the SYN flood. So it's an incomplete three-way handshake, half-open TCP connection. They go by different words, and you got to be careful when you're taking a test. Don't memorize one specific answer. Know the concept. Know what's going on. As far as the rest is, as far as the test goes, it's nothing testable, but there's something that annoys me. On the session teardown, it used to be something like this. You would do a FIN, and then someone would do a FIN-AC, and then you'd FIN-AC. But now I notice things have changed. They just go FIN-AC, and then the host says the same thing. And I don't know of any real problem. It just annoys me because it reminds me of my girlfriend, because she'll call me like this. Hello, it's Larry. Hey, Larry, it's Char. Connection established. Could you pick up milk on the way home? Data transfer. And then she says, okay, bye. And she just hangs up. And I wasn't really ready to hang up. Now, I'm sure if it's Microsoft, I would say, oh, but we wanted to give you this other information. No, you hung up. But this really bothers me, too. She'll even do this. Hello, this is Larry. Hey, Larry, it's Char. Three-way handshake completed. Could you pick up milk on the way home? Yep. Okay, because I was beep, 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 beep. Oh, wait a minute. I got 5 bars. It's not me. She doesn't call back. And you know, I'm half Irish, half Jewish. But a Jewish grandmother of me comes out and I go, oh my God, she probably got in an accident. And they call it, yeah, what happened? I lost my connection. Why didn't you call me back? I already asked you what I was going to ask you, but I wanted a graceful termination process. That's too much overhead, you geek. Whatever. But this is very important to us. Now, if I send you a SYN on port 80, and you are a web server, you will SYN-AC back. What do you think would happen if somebody sends you a SYN on port 80 and you're not a web server? It's very important to a CEH or anybody monitoring their network.
You can't SYN-AC back.
You're not going to SYN-AC back, right? So it'd be very rude to not answer them. You want to let them know. So they decided to say, look, I heard you. It's a reset I'm drawing here. It's RST, and we're going to see this closer. I heard you, but I'm not really a web server.
Right.
Why did somebody send me a SYN on port 80 if I'm not a web server? Let's take a step back. The way this usually happens is I don't type SYN80 to some IP address. I go to my browser and I say www.microsoft.com. When my browser says, you put in www, I'll bet you mean port 80. And when you said Microsoft.com, they ask a DNS server, a domain name server, do you know where Microsoft.com is? And the DNS says, yes, it's at this IP address. If someone's sending me a SYN on port 80 and I'm not a web server, they didn't get it from a DNS. They are scanning my network. And that's a top indicator that you're being scanned. And today I hear from most experts, that's very likely a botnet. So we're going to take a look at these flags closer, but resets are normal. Sometimes I see it when I didn't log out of Yahoo, I just closed my browser, and my browser sent a reset. But not more than 1% of my traffic or so should be resets. So let's take a look at this a little closer. So again, using Wireshark, I could actually sniff these fields. So these are the, again, I take a letter and I put it in a TCP packet. And I write in not just the port number, port 80, and my source port or something higher than 5,000. Because TCP has those extra services, it's reliable, it numbers every byte in the connection. And the receiver will acknowledge every byte. Now that sounds like a lot of overhead. So if I wanted you, Alicia, to acknowledge every word I was going to say, I want to say, are we ready to move on? And I go, are. Yes, Larry. We. Yes, Larry. Ready? Larry, I can cache a sentence. Well, that's what these windows are for. So if you look down here, this window field, and with 16 bits, well, 2 to the 16th, if I had 1 bit, that would be 2 values, 2 would be 4. With 16 bits, I have 65,000-ish possible ports. Excuse me, 65,000-ish possible bytes that could be acknowledged, be sent without acknowledgement. Let's pick an easy number. I've got 1,000. I have a window size of 1,000. And I send you bytes 1 through 1,000. The way TCP is written to be reliable is that you will ACK, actually the next one you expect to see. So you would ACK 1001. Right? So again, I send you 1 through 1000, you got them all. It's like I sent you a train with 1,000 passengers and you go, I got all 1,000 passengers. You can start sending me more starting with passenger 1001. Right? But now I send you 2000 or 1001 through 2000 and you missed 1002. Well, since you didn't get it, you will ACK 1002. And I'm going to send you 1002. Well, don't want to get too detailed, but TCP will say, you lost a packet, let's make that window 500. But I'm still going to send you 499 passengers that already got there. Now, not on the test, but if you're ever troubleshooting your network, this is very important to know that you can actually expand that number and you can tell people just selectively, give me the one that's missing. So good. Let's take a look at what I'm talking about here. All this is negotiated on a three-way handshake. So if I just pull up any capture and and I look for all SYNs. So here's a SYN. This is a server talking to a machine. You say, oh, I drew up on the board, I sent you a SYN. There are options. And in this case, it does support selective acknowledgement. TCP has been modified and most people don't realize it. And when it was modified, and people like me did realize it, I realized it in a security class. And for instance, I taught Cisco, managing Cisco network security, and they said options are great. They could speed up things a lot. But on the outside, at where your outside router hits the internet, turn them off, because people could find out what type of router you have and focus their attack. Now let me take a step back, 2009, and one of my heroes in this field, the woman who knows everything about Wireshark, she writes the certification class, is Laura Chappell. Laura Chappell was giving a talk to 200 or so people. And let me step to the board, just to get my best Laura Chappell. And she says, she's troubleshooting a problem, and she says, why is it so slow? And she goes, oh, and here's the problem, just as I told you, at the perimeter where I hit the internet. She goes, someone decided to turn off all options. And I raised my hand. I said, isn't that considered best practice to mitigate reconnaissance attacks? She goes, oh my God, are you a security guy? Yes. I hate you people. Let me guess, you were worried that somebody might figure out you have a Cisco router. They just narrowed you down to one of 80% of the world. And you, in the meantime, literally made it 250 times slower. I hope you're proud of yourself. And when a woman insults me like that, I get a crush on her. But she's right. And I always tell my students, you know, security is important, but don't over-secure it. If we do this wrong, we look like TSA, right? So security is important, but don't make me wait at the red light when there's nobody coming. It's just wrong. Don't take my nail clipper. It was just silly. You let me have my belt, really, but the nail clipper was dangerous. So on a test, typically those were things you would turn off, but TEH does not cover those things. You as a network troubleshooter definitely want to know how to support these options. They make a huge difference. But getting back to the other fields in here. So I have source and destination port number. And again, my source port is dynamic. So I'm going to take something above 49,000 for my client, and I'll talk to the well-known port or something registered. Sequence numbers and acknowledgement numbers, again, number every byte, or bit, I should say, every byte in the connection, so I know that you got it. That's why it's reliable. The header length only varies because of options. The reserve bits we don't care about, but these flags are extremely important to us. They're going to be important to us now in doing reconnaissance and understanding when we scan what type of machine is that, what type of service is listening there. But it's also going to help us understand how firewalls work. And when we try to filter these things and understand, it'll help us understand how IDSs work in later modules. So this is really good knowledge to have. All right, so these flags, 6 basic flags. Urge, I've never actually seen used in valid traffic. I read the RFCs, and the RFCs say, well, I could have like 20 browsers open at one point. And one of them, I made a big mistake, and I go, oh, Control-C. I want that to be processed now. But I don't really know if it's ever been used validly. I've never sniffed it out, and I sniff a lot of places. ACK says, I heard you, right? I acknowledge what you said. Other than the initial SYN, every packet has the ACK flag. So now you're in early stateful firewall. And you want to say, no one's allowed in here unless somebody on the inside asked for it. So that means if you walked up to the door and say, I got a box I want to give you, they'd say, no. But if you set the ACK flag on that packet and just go, somebody asked for that box, they go, oh, come on in. So it was an early way that hackers would bypass these, typically they were routers with access control lists on them, but they'll call them on the test, early stateful firewalls by setting the ACK flag. So you want to know about ACK scanning and stuff like that for the test. All right, push says don't wait for my window because I have a window size of 16 bits, say 65,000 bytes before I say I got a truck and hold this much. Don't send the truck out until it's full. But if I'm typing a telnet command, and the way that works is I type in a letter and it goes to a server and then it comes back to my screen and echoed back to my screen, I don't want to have to wait till I type 65,000 keystrokes. So push says don't wait, send it now. Reset can be normal. Reset can be, again, I've seen servers just say, hey, I haven't heard from the client in a while. Maybe he timed out. Let me just reset it. Clients, same thing, might reset it, but shouldn't have a lot of those. And the biggest time I see it is when people are scanning you and you're not listening on that port. Let's take that again, because that could be very interesting and very important for a CEH candidate. So if I send you a SYN on port 80 and I get a SYN-ACK back, I know you're listening on that port 80. But if I send you a SYN and the firewall says you're not allowed to send SYNs in here, let me just send a reset and see if it'll get passed. Or excuse me, send an ACK, see if it'll get passed. So, see if I send an urge, see if it'll get passed. The 3 scans that you're going to see on your test that did possibly bypass that thing says no SYNs. I'm not letting a SYN in here. I could set the FIN. So it's kind of like if someone says hi, don't answer them. Hi, hi. If instead you say bye, they go bye-bye. So you elicit some response. You could send what's sometimes called a Christmas tree scan, which has changed over the years. But if you're taking this test, it is when you set urge, push, and FIN. And if you ever have a question, try it with Wireshark and sniff it out and see what you saw. So don't worry about what the book claimed. What did you see? But all of these work the same. I could set nothing, also known as the null scan. So these 3 scans that are going to show up on your test, FIN scan, Christmas tree scan, urge, push, and FIN, and null, if you're listening on port 80, I would get nothing. But I might have gotten nothing because a firewall blocked it. So I can't really say that you're listening. But if you're not listening, you send me a reset. And the use of that is, well, at least you're a live host. So I just want to know if somebody's behind that door. Now, if Bob's behind that door, he won't answer. So I go, Bob, and he's behind it, he doesn't say anything. So I go, Steve back there? No. All right, somebody's in that room. So again, on your test, there's going to be a whole bunch of focus on the difference between knowing that you're looking for a listening host versus a live host. I'd much rather know you were listening. That gives me more information. So if you're, say for example, I send you a SYN and you give me a SYN-ACK back, I don't have to complete the 3-way handshake, do I? I know what I needed. I don't set the 3-way, and that's called a SYN scan. The SYN scan, go to the board, just to reinforce that. The client wants to know if you're listening on, say, port 25, and he sends a SYN. Synchronize with me. And if you are listening on 25, I get a SYN-ACK. There is no reason to complete the 3-way handshake. I have what I needed. I wanted to know if you were listening. Good enough, you're listening. That is sometimes called the SYN scan. Since it doesn't register as a connection, it might be called a stealth scan. And it's also known as half open because it left it half, it never fully completed it. Half open. And on your test, you might see, why did Bob do this? Was he doing a SYN scan to see if it was live? Was he doing a stealth scan to see if it was live? Was he doing half open to see if he's listening? Well, they're all the same thing. It's not the first word. You want to know that it's listening. That's better information. All right? So 2 things we're going to do out of our scans today are understand, hopefully you're alive. Better information, are you listening on that port? Let's go to the rest of it. So I've got reset, close, SYN, synchronize with me, FIN, bye. Now, FIN is a very nice goodbye. That's like, bye, I love you, but they're still talking. And, you know, you have family like that. Okay, I just want to tell you, okay, yeah, all right, bye. But reset is click. So it might be important to understand for your test that once I send you the fin, if you have things to tell me and those sequence numbers are lower than the last ACK, of course you're allowed to complete that. Would it ever seem right to see SYN and FIN set in the same TCP header? Would it ever make sense? Hello, goodbye? No, it doesn't make sense. Would you ever see that? Yeah. And why? See the look on your face? Because if you never told people what to do when people act really weird, different vendors will do different things. So this is how we might guess, oh, that's Microsoft, that's a Macintosh. So that by sending weird things, and just to see how they reply. Cool. And again, we can sniff these out with Wireshark, and we can see the flags. Now, these first two flags, ignore them. No, I've never seen them used, and I wouldn't certainly not worry about these tests. But you can measure these with your TCP, with your Wireshark tool. UDP does not have a lot going on. UDP is a very simple protocol. The benefit of this is it's much faster. It is not the brightest thing. So if FTP uses TCP to transfer a file, it's like using FedEx. The FTP application doesn't check to see if everything got there. It's FedEx, of course it got there. But TFTP, the Trivial File Transfer Protocol, uses UDP. So when you write an application like that, you go, dude, you better check those boxes. So the application has to provide that reliability. Right? The speed, though, is kind of neat in a way that if I'm worried or just pure performance and I'm sending things to multiple users, you might see a lot of UDP. But I always think of something my mom says, it's kind of embarrassing, but she used to say that, Larry, I thought I was fast. Larry's not the brightest kid. So one time she asked me to run to the store, and I grew up in the inner city, we were at a row home, and there's a store, they know everybody. And, Larry, run to the store for mommy, and I ran to the store as fast as I could. I'm like 11 years old. Yes, Larry? Mom told me to run down here. Tell you what she wanted? Nah, I don't know how to help you. Yeah, you meet her, she'll tell you that story. I go outside, she's standing on the porch with a note, and she loves to tell people. He wasn't the brightest thing, but he was fast. All right, we can sniff these out, again, with our Wireshark. Now, all of these are bundled into an IP datagram, you might hear it, or packet. Let's go back to that drawing we had here. So this is the information in the packet header. So we don't just say source and destination IP address, there's actually a couple other fields in here. So there's a header length. Whenever a header length varies, that's because of their options. And I only know of one option. We see it down here, and it's bad. Now, I'm a network ops guy. My job coming up was always, really, I want to play music, and I don't want my help desk phone to call. I don't want any users complaining, so I would use network monitoring tools, try to figure out problems before they happened, and then keep people from bothering me. But hackers looking for a different perspective. So one of the options available that we would never allow is IP source route. I like my routers making the routing decision, not a packet going, don't worry, I know my own way around here. But there's an option to do that. Well, we always stop it, but on your test, if you're taking CEH, remember your perspective as a guy trying to break in. So when they say, see if they allow IP source route, try source routing, they mean as a hacker. So that's why I have to have Tom in this class, because he's more of a hacker. I'm always the ops guy. All right, type of service, actually very, very important stuff if you're a network guy today. It was, another thing that reminds me of the Titanic. Up until the radioactive 1912, we had no way to prioritize calls. So when this junior operator of 22 years old is getting distress calls, the senior operator at 25 saying, I'm busy. And he's processing telegrams. Telegrams are like, I'm having caviar. I hope you're enjoying yourself. And they said, no, distress calls have to be prioritized. And today where we see it mostly is in voice over IP. So if I'm, working online and my girlfriend's, my daughter says she's watching One Direction videos, I make an IP phone call, and suddenly the network's really busy. She should be dropped before I am. That's what these type of service bits, also known as DSCP bits, are for. Outside the scope of this class for now. Personally, I'm always thinking how, I bet you I could create a hack, set the quality of service to be the highest value, and my denial of service will have to be processed before anything else. But we'll save that for another talk. All right, now these other things go together. Total length, ID, flags, and fragment offset. Let's take a look what that means. All right, now, down here I said we're going to worry about these things later on, but a machine really doesn't just have these addresses. There's something called the network interface card, and it can create frames to carry these packets, and these frames can only be so big. They're known as the maximum transmission unit, and they have changed over the years. So when I started out, there were a number of competing technologies, and two of the more famous were token ring and Ethernet. A token ring network interface card could create a frame or an MTU of, and it would really go a little higher, but most people will quote 4,000. So I have a token ring workstation, and it creates this 4K frame. It's connected to a router, and the router has to break it up because Ethernet doesn't support that size MTU. Ethernet, standard, allows for an MTU of 1,500. This would be analogous to say he's allowed to use, he's got ships, but when we come up this waterway, there's smaller boats, and you just can't fit in the river. So or a tractor trailer to minivans. And the router's job is to break this into smaller fragments. And these 4 fields are set. Now the total length, and if we look at that field, it's actually 16 bits. That would allow a packet length, a payload length of 65,536. I've never seen one that big. Now it's going to be 1,500. Total length equals 1,500. Total length for this guy also equals 1,500. It was originally 4,000, 15, 15, 3,000. So the last one, total length will equal 1,000. And now this all adds up to 4,000, right? All right, so we broke. How does he know they're part of the same packet? He could be getting all kinds of things. We're going to set this ID field. Now the ID field is allowed to be a random number. Random numbers take a little bit of thought process. Random, let me think of a number. So most OSs just use a stack. I'll start at 1, then go to 2, go to 3, whatever. The important thing to the receiver is that they're all the same. So ID equals 23. ID equals 23. ID equals 23. So now this guy knows. All right, they're all part of the same frame. Then there are flags. Flags that say things like, oh, don't fragment me. Well, obviously that's not said here. So we're going to say more fragments follow is the other field that we care about. More fragments follow equals 1. Yeah, I have another one. More fragments follow equals 1. Yep, there's one more. And then finally, more fragments follow equals 0. And now there's an IDS in here. And he's looking for malicious traffic. And they know about fragmentation. So when it sees a 1, the IDS says, don't run your analysis yet. We don't have a complete look. But if I could get a bot, some piece of malware on this machine that says, don't wait for the last fragment because I ain't sending it. People have historically eluded intrusion detection systems manipulating these fields. We're going to have a whole chapter on IDS evasion, but I just like planting seeds right now. And then the last field is fragment offset. Where do these fit together? So this is the first one. He's going to say this box goes here. This is fragment offset equals 1. Now fragment offset, this is 1,500 bytes later. So when I piece these things together and I'm going to tape them together, I know to go 1501. Make sense? So now this box goes here, and this box goes right next to it. There's 1 through 1,500. Here's 1,501 through 3,000. And then the last one, the fragment offset, would equal 3,001. But somebody came up with an idea. He's like, dude, I sent this guy a bunch of fragments, all with the same fragment offset. Oh, this fragment goes here, and this box coincidentally goes in the same memory address space. There's an old denial of service attack called or actually teardrop. There's been a few variants of that, new tier, boink and bonk. We're going to have a whole section on denial of service, but fragmentation has been used not just to rebuild packets, by many hackers to do all kinds of things. One of the attacks hasn't worked in like 12 years. We call this dead yet testable. Shows up on every IT security test I've ever seen. All right, so I send you a bunch of fragments. Now remember, the total length field is 16 bits, so the largest any packet could really be would be 65536. If you were counting at 0, you'd say 5. All right, so let's imagine we're at 65534, and I say, oh, I have another 1,500 bytes for you, and the fragment offset is 65534. You will now try to build a packet that it ever be large. And if this was the 90s, you would go down, it was known as the ping of death. Twice on the CEH test, there are times when Bob attempts this. They go, what's he attempting to do is the question. And you want to say denial of service. What I really want to say is an attack that hasn't worked in 12 years. I don't know why he's attempting to do this, but just know it's the ping of death. And they don't actually ask ping of death. They just want to know it's a denial of service. TTL stands for time to live. So that's the next field in this packet header. And the TTL is not really time. It's every time I cross a router. So if I started with a TTL of 8, and actually this is a true story. So Tom and I go to a talk at SharkFest, and a very unassuming man, Van Jacobson, gets up and he tells us how he was working for the internet bigwigs in the 80s. He's out there flunky, you know, and he says, could you troubleshoot this problem? And the problem, actually, he got a very testable ICMP error message, type 11, time exceeded in transit. That could be important. He said, well, look, what is that? Oh, that's the TTL that expired because he crossed too many routers. So a router's job, besides looking up a route, is to say, decrement that TTL. And if it gets to 0, tell them you can't get there from here. That's far. So he looked at it, he said, well, the TTL, and I think the number was 8, those are the very old days. He said, so I made it 9. And the next router did that to me. And I got an idea. I was like, no, you didn't. He created a tool called traceroute. Traceroute will start off by setting the TTL, like I want to go to traceroute. Let's try it real quick to in fact, we'll try SecureNinja. So I'll do Microsoft's trace RT is a little bit different, but I'm going to say www.SecureNinja.com. And what it's doing is it's trying to get to the SecureNinja site, but it's set the TTL to 1. So I'm getting an error message now that you can't get there from here. And that first one is 12.104.45.65. That's a router. I will eventually build a list of every router between me and the target. That's very handy as a troubleshooting tool. Again, I'm a network ops guy. So when I was coming up in the 80s, 90s, particularly the 90s, we would need this to troubleshoot a problem. Hackers do this also, though, to find out all the routers between you and between them and the target. So a very handy tool, traceroute. And we'll let that run in the background. Protocol will tell me what's in this IP packet header. So it could be TCP, it could be UDP, and something on the test you want to watch out when you scan something that looks really close. When you do your Nmap scans, and Tom will walk you through these things, and you'll actually see how the scans work. But there's a -O, and that says what operating system. There's also a question that has -S, small s, O. That is different. That says what protocol is loaded. And particularly, probably why a hacker would do that is to look for, maybe you have IPsec loaded. That could be a way to get in there. That we might say, and that would be protocol 50 or 51. But it is a test question, and you do want to be aware of that. The header checksum is an error detection mechanism. So if one of these fields goes bad, the checksum should be bad, and then you go, no, that doesn't add up to the right number. Wow, if routers decrement TTLs, they're going to have to modify checksums. Could that help a hacker? Yeah, check this out. All right, so again, I'm planting seeds early. We're going to do more of this in IDS evasion, but let's imagine that here's the victim, and the IDS is on the same segment as the client, as the attacker. The attacker might be able to send attacks with bad checksums, but the router's job is to be fast. So while a router has to decrement the TTL and recompute a checksum, they don't always examine incoming checksums. So you send a bad packet, the IDS goes, it's bad, don't need to worry about it. Router fixes it, and the victim gets hit. Awesome. All right, source IP, me, right? Source IP destination IP, should those ever be the same? Should I ever see a packet that has the same source and destination IP address? Would you ever mail a letter to yourself? No. But will you see that when you look at a sniffer or an IDS? Yes. Why? Why would somebody do that to you? Get you chase your tail. It's known as the land attack. It's an older one. Most systems have been patched, but earlier systems would chase their tail. You say, hey, get back to me forever and ever with the largest packet you supply. By the way, I'm you. And they would just keep running around in circles. So again, we say options. There's only one option we know of. It's source route. As an operator, I don't want to support it. As a hacker, if the target supports it, you use it as a covert channel and you can bypass some of their security controls. All right, the padding just has to be there because options have to be on an 8-bit boundary. So if that's a 5-bit option, I have 3 bits of pad. All right, and again, we can sniff these out with Wireshark and see these things. So again, it's not just a matter of opinion, I can see it. And that's what I like when I can show people evidence. Most of my job as a troubleshooter is really proving that it's not our network. All right, IP6 they introduced as a couple of things for the CEHV8. That's a great introduction to it. No labs yet. Hopefully that'll happen, but we're looking at adding some labs ourselves. Now, one of the great things that happens is it's a fixed header. There is no more fragmentation we're going to worry about. At least routers won't do it. That's a great thing. It also has a much larger address space. At 32 bits for IP4, if we go back, in the IP4 address space, we have 32 bits for the whole world. You have 128 bits for the whole world now. You have 64 bits for your network. So think of this scanning now. If I'm going to do an Nmap scan and I'm going to send SINs to people to see if you're alive, how long do you think it would take to do the entire world right now at 32 bits? That'd probably take a long time. And then in IP6, you have 64 bits. This type of reconnaissance has to go away. And probably the bigger target, and one of my favorite IPv6 security researchers is Van Houser. He runs the Hacker's Choice Network and TAC Scan. And he predicts that DNS will be the big target for reconnaissance because it has the list of the host name to the IP address, which we learned in an earlier module. All right, and these are what you would see in an IP6 header. And since there's nothing too hard that I know on the version 6 test, I don't want to beat it up too much. But IP6 does fix a lot of things. It is increasingly complex though, and we have a hard time securing the IP4 world. So even though IP6 fixes a lot of things, I expect it's only going to be a very troublesome changeover, and we're going to have a lot of issues doing this. And I don't like to pick on people, but I kind of pick on, I blame most of my problems on myself. I really believe, I've been studying martial arts most of my life. I've never been attacked by ninjas. I have, well, I really got yelled at by my oral hygienist because she says I had gaps between my teeth that are larger than they should. Mr. Greenblatt, you're interested in self-defense. Do you ever think about defending your teeth? Yes. I mean, she was really yelling. She goes, do you know how to floss? I said, yes. No, apparently you don't. And she was so mean that I told you, I get a crush on people like that. So I was like, you follow me around, and when I mess up, just like, I don't think you can afford me, Mr. Greenblatt, and I'm quite certain your insurance won't cover it. But there are problems that aren't me. You know, I'd say maybe 20% of my problems aren't me, and I blame my sister and her kids. And honestly, I think that we have a hard time getting workforce. And you know, Jesse Jackson can make things rhyme that shouldn't rhyme. I created a Jesse Jackson rhyme to describe a real predicament and what I worry about IP6. I go, in China and in India, children study to be engineers, but our children study to be Britney Spears. And I just worry that our kids aren't interested in it. So you know, John and I were told, we were kids, we wanted to be astronauts. We need to make this cool. We want kids to want to be security professionals and secure this IP6 network. It's like, you know, it's a great time we live in to build this infrastructure, but it just doesn't seem cool to the kids yet. Maybe with this thing. Now, a great protocol that was also developed as part of the TCPIP suite is a maintenance protocol called ICMP, the Internet Control Message Protocol. And it's just there to check status of the network. And they send you all kinds of, oh, you can't get there from here because of, and I mentioned that one very testable ICMP message when the TTL had expired. It's an ICMP type 11, time exceeded in transit. Well, some messages will, all messages will have a type. So if I did a ping, I said a type 8. Some types will have codes. Destination unreachable. Why? And we'll find out. Now we have a checksum, but optionally there is data there. Now the way the data is supposed to work is if I send a packet to you and I can't get to you, I get the nearest router will come back destination unreachable for whatever reason, and my data is in the data, and it's a way to show me it's a valid reply. Oh, but I could probably put just about anything in there, couldn't I? Yeah, first tool I ever saw could do this, and I'm just going to pull it up from Google. But if you allow any ICMP message to get through using a tool like Loki, people can use that to send data. So just looking at what port numbers are running or this, that's going to tell you what people overtly are doing. But when people are doing things covertly, they try to hide under anything. You can send anything through anything. You think you're not running LimeWire? Take a look, because ICMP could be used to send anything. Pretty cool. So again, it's a great troubleshooting tool. That was interesting.
That scared me.
Okay, ICMP is a great troubleshooting tool. I could not troubleshoot a network without it. As a network ops guy, I absolutely needed to know when it was there and be able to use it. But hackers have found ways to, well, do reconnaissance, are you alive, and also do a covert channel and send data through there. And then they've even done something else. I can ping an address, maybe a broadcast address. So I ping the entire network and I say, everybody get back to me. Let me know if you can really see me. But I don't use my IP address, I use yours. Everybody try that forever and ever until I say stop. And that's known as the Smurf attack, and it's a very common distributed denial of service attack. So again, we're going to have denial of service later, but just so anybody pay attention, it's nice to pass seed. When I did the SYN flood, I overwhelmed you with SYNs. That was a denial of service. You eventually couldn't answer. But when I had a whole network of machines get back to you with ICMP unreachable messages or ICMP whatever messages, I can get echo replies. I have, like Smurf, this is a distributed denial of service because there are multiple machines involved in it. And today with botnets, these are really bad. It gets to the point where we're talking, the largest botnet I read of was about 30 million machines, but even things like Zeus, Configure, they are up and down around 6-7 million machines. So that's a lot of stuff. When we talk about penetration testing and you know, you're going to set rules of engagement, what test should we try? You might want to try a SYN flood. I don't know too many people want to check to see if they're vulnerable to a distributed denial of service attack, because the answer is yes, you are. This is what you might remember using a tool called LOIC. The WikiLeaks people brought down MasterCard and PayPal and a number of other sites. All right, these are the messages, some of the messages you'll see in ICMP, but for any CEH candidate, you want to focus on a couple of these. So we know that the most common tool for ICMP is ping, and that's echo request and echo reply, no codes. Type 3 could be unreachable for many reasons. Now, if I send you, let's go back to TCP scanning. Remember I said if I send you a SYN, I SYNAC back, I know you're listening on that port. If I sent you a FIN and you were listening on that port, I got nothing back, right? So that doesn't prove that you're listening. Could have been blocked by a firewall. But if I got a reset back, I knew you were at least a live host. UDP is not stateful. There's no such thing as a SYNAC. But if I send you, say you're a TFTP server, you'd be listening on 69 by default. And I sent you a packet on 69 and you are, I get nothing back. So I don't know. But if you're not listening, I will get an ICMP type 3, code 3 message, port unreachable. And that will be important to any CEH candidate. So again, these can only prove that machines are live. Type 11, I mentioned, be very important as well. This is time exceeded in transit. And another way this can help when we do our firewall scanning later on, but just again, I don't like to plant seeds. I want to know if a firewall is allowing a port through. So I've got this firewall here, and I don't know what it allows past here. And maybe I've got a web server here, maybe I've got a target mail server, I don't know. I'm on the outside. I'm coming in from the internet. Doing my trace route, I may have figured out that, wow, that firewall is 15 hops away, 15 router hops away. I'm going to try to do scans like SYNs or whatever, but I'm going to set it to 16 hops. I'm going to scan 16 hops. And that's only going to make it to this router, because the router will not decrement it any further. Well, if the firewall didn't let anything through and I send a SYN to somebody, I won't get anything back. But if it's allowing, say, port 80 through, this router is going to go, oh, you can't get there from here. And I get that time exceeded in transit message. The tool will worry about that on firewall. It's called Firewalk. So Firewalk's job is to set the TTL on any one packet to be one past the firewall to elicit these type 11 messages from a router to determine if those are allowed through. And we can sniff these out again. I love Wireshark. Prove it, I always say. Now, look at this packet. It says it's ICMP. The version of IP is 5. There is no such thing as version 5. The total length is all ones. I have never seen a packet that is 65535. The ID field spells out in hex bad. That cannot be good. The flags say do not fragment me, and there are more coming. Now, when I have an address, the destination of an address could be a single machine, but I might broadcast to everybody, or I might just say, hey, everybody with real audio loaded. You know, this is the multicast. But the source address here should always be unique. No packet came from everyone, but this packet says the source address is 255.255. That means everyone sent it. And yet the checksum is still good. Because this tool, now this is an old packet crafter, for your test, you're going to be using HPing 2 to craft packets, and HPing 3 will be your scripting tool. But I just find this a pretty handy tool because it's graphically based. Actually, there's a nice one that comes with your tool set as well now. You get a trial version of CAPS's Packet Builder. Fantastic tool. But let's just take in a packet here. And it's kind of funny. I did this at a hotel, and I'm not the type of guy who would try this, but pick up a sample hotel. All right, so first I'll just take any packet and I'll edit it. And we'll take that, the packet header. So here we go, version 4, which is what we typically see on the internet. But I'm going to take that destination, or that source address. I'm going to make it all ones. And now it's, but look, the checksum is incorrect. It tells me that this checksum value of 0x, 0x means the following number is hexadecimal, 0x AB1F, that's incorrect. Why, it should be C7C7. Oh, it should? There, now it's a good packet. So at the bottom here, I can say send one, and it's processed as good. People can lie on the envelope. When they put the letter in the envelope, they can lie, you know. So you want to trust people. You know, that's what a lot of security is. It's just taking advantage of the fact that people are trusting. And when we get to social engineering, I always say, I'm just a sucker too. In martial arts, we know that there's just a critical distance line of about an arm's length away. If somebody gets within that distance, I don't care if you're Floyd Mayweather, they could hit you and you don't have time to react. So a martial arts technique is it's always to keep people at an arm's length. But then when my mother wants to give me a hug, because you could hit me, and you think I learned because nobody's hit me more than her. So give me a hug. That's for not calling. I thought you were dead. But whatever. Live and learn. Actually, I don't learn. All right, so when we scan on the test, you're going to be using the best known tool in the world. It's called Nmap. Now, this is a very old GUI screen here, but I like to show it still because everything's on one screen. So if you look at these, the options here, Nmap allows you to send any combination of ICMP message type, any UDP port number, any TCP port number or flag combination, try fragmenting it, see the look on their face, and try to determine what it is. And in this case, this was able to guess that it was some Linux system, and probably based on the fact that it was listing on ports 22 and 98, 111. These are known Linux type ports. But to get a valid reply, I have to use my real IP address. I don't want them to know that it's me. Well, I have a couple options. I could, over here you see decoys. I only need one packet back. I could send 10,000 packets with 9,900 phony source addresses. Makes it a little trickier. Or, so they're a little tricky for students to get, but let's try and follow this through. If you're not listening on a port, I get a reset back. Recall that? I want to know if somebody's listening on port 80, and I don't want them to know it's me asking. So I ask somebody else. I pick anybody, a zombie. I'll use you, Alicia, to see if John's listening. I send you a SYN, and you give me a reset. I'm not listening on port 80. I'm not worried about that. I want to know the ID field. Remember that ID field? And I said it's usually a counter. Let's say it was 100. Try it again. 101. I know you're using a counter. All right. Now I'm going to send to John on port 80, but I'm going to spoof your address. He's going to think you said it. If he is not listening, he's going to reset you and go, no, I'm not listening on 80. And nobody answers a reset. So I scan you again, and you only incremented by 1. I go, oh, he didn't talk to her. But if I send him a SYN on port 80 spoofing you, and he is listening, he'll SYNAC back to you. Well, you go, I didn't ask to talk that, and you reset him. Your ID field just went up by 1. So then I scan you again, it says, oh, she incremented by 2. He may have answered her. Of course, you could have been talking to somebody else. So I have to use somebody who's not talking to anybody else, somebody who's very idle. And that's why this scan is known as the idle scan. The idle scan uses a zombie host, checking their ID fields, and then using their address to spoof when you talk to the server. Again, if the server is not listening, the next time I check them, they incremented by 1. If they were listening in SYNAC, they would have incremented by 2. Very crafty way to not use my IP address. This is a more modern version of the GUI for Nmap now. It's called Nmap. So it's a scan of my house. I was able to find everything I had. Now green means I'm not listening on too many ports. So you see a red there? I was able to identify my firewall. But port scanning tells me what you are at best. All right, so now I've been able to build a list of live hosts, maybe just by pinging, maybe because I got resets. I've been able to get whether or not you're listening, if I got SYNACs back, so both my three-way handshake, which is known as the connect scan, or the send scan, will tell me if you're listening. But what are you vulnerable to? I mean, maybe I identified you as whatever, Windows 2007. What is that vulnerable to? Well, we have tools to do that. Now I could go to the MITRE database, which I like to get to, National Vulnerability Database, and it will take you to a list of all the known vulnerabilities that we've maintained on computers. And I could look for Microsoft, or I could just, if I click in now, I'll just see what they've learned today. And let's see, just again, this was discovered today, 5/29, right? So they can find these vulnerabilities. I could try this manually with Telnet, but I'm not that great. It's going to take me a long time. A real hacker would have to do that. If somebody's really trying to break into the United States or China or some bank, they're going to have to be very manual about this. But I'm a security tester. I can run a tool that just fires all kinds of stuff that would set off alert. Security would notice somebody's talking. But I could use a vulnerability scanner like Nessus or Nexpose or LandGuard. There's a number of them out there that maintain databases of those known vulnerabilities and tests to see if you are vulnerable. Now, generally, the reason you're vulnerable to an attack is either you don't have the latest patch, or you're patched fine, but you left, say, the administrative password blank. So it's either a version problem or it's a configuration problem. So we're going to scan regularly. I want to know if I'm vulnerable before the attacker does. So it's important that we scan regularly in our networks to identify any active and vulnerable service and make sure that it's within our policy. Sometimes you find people loaded things that they weren't supposed to load and they meant well. Sometimes you find something that turns out to be a business application. You didn't buy it, but it showed up because somebody developed it there. A salesman was good at developing something, and you need to enable it. But you have to know your inventory. You have to know what you have. All right, so the MITRE database is a database of known vulnerabilities and exposures, and I was very happy to see they started incorporating phone vulnerabilities too, something that goes along really well with the V8 material. That was a big problem because every time Microsoft or Linux or Macintosh has a problem, we put it here. But phone vulnerabilities, iPhone and Android, they were not until recently, and now they are. It's a very good thing. MITRE has a list of all these things, but to query the database gets a little cumbersome sometimes. So you saw me. I like to go to nvd.nist.gov. And earlier today, I saw that there was actually a new Android vulnerability discovered. When they discover these vulnerabilities, and we're coming to the close of this module, first of all, they probably wouldn't have published it if they didn't think, in this case, Google was looking at it. And Google's aware of it and maybe even has a patch ready. Sometimes they won't give them time. You're taking too long for the patch. We got to let people know. But either way, somebody might come out with exploit code before a patch comes out. And if that happens, we have what's known as a zero-day exploit. There's no defense against those. Tougher job is the patch comes out, but you can't patch because it breaks your server. So much of security really is patch management. All right. So using Nessus, which is what you'll use in your CEH class, easily the best known vulnerability scanner. Nessus will maintain a library, so as we just saw, these CVEs got updated. I go over here, the people at Nessus are updating their tool to look for these vulnerabilities. You'll scan your network and you'll find these vulnerabilities. This is a scan Tom's done earlier on a Windows machine. And looking closer at it, you can see, and it's a little small font down here, but where I'm moving my arrow, it will reference the CVE number. So that will really help you in understanding how to mitigate that vulnerability. Right? So that's it. We've understood now, hopefully we have a nice introduction to how computers talk to each other using IP to identify the machine and using TCP or UDP to identify the application that's listening. I can find live hosts and hopefully even determine if it's listening on port 53, then I'm going to guess it's not just a live host, that's a DNS server. And we talked about, now that I know what you are, what are you vulnerable to? So moving on with later modules, when we get into system hacking, it's really about validating that vulnerability or exploiting the vulnerability. As a tester, I always think of validating vulnerabilities. Hackers tend to think exploiting it, but really the tester does have to exploit it. So if I warn a student, you're dropping that backhand, and he's not listening to me, hitting the student will make him realize. So that's why we often say to see is to be deceived. To hear is to disbelieve, but when they feel it, they'll perceive. So Alicia, do you have any questions?
Yes. These tools that you're using, the scanning tools,
Yeah. Nmap, Nmap. Nmap is the front end, and Nmap is the underlying tool.
Okay. Where do you get these tools? Are they free?
Nmap.org. It was developed by Gordon Lyons, known as Fyodor. He's got a whole team of developers. Very well-established tool and free to the community. It's actually a tool, it's kind of cool, used in Matrix. Trinity uses it to scan the network, and it's kind of funny. I was talking to Gordon, and he said, he wrote a book, and it's a fantastic book on Nmap, and he put a picture of Trinity in there, and Paramount Pictures had a lawyer contact him and said, you got to get that out of there. You know, we never gave you a right. He said, I didn't give you a right to use my tool in your movie. So he just printed the guy's business card in his book, and you know, they could have gone after him soon, but that's probably a bad idea to go after Gordon Lyons, because everybody in this community loves Fyodor. He's a great guy, and I just think that would be a big mistake. But Nmap is totally free, and anybody can download it.
Awesome.
Yeah.
Where can I go to learn more about scanning and all these?
Well, you know, it's amazing. They've got YouTube things for everything. I did want to point out that the vulnerability scanner I showed, Nessus, is not free. You can download a free version, but remember I showed you these vulnerabilities as they get updated. These have to go into the Nessus tool. So what Nessus does on the free version, they don't give you the latest vulnerabilities, but it's certainly enough for you to get started and try it at home. And I've only used the free one. But there are other ones that cost money, and they're great too, so I don't want to just stop there.
Cool. Yeah. Now on the security side of things, what can I do to defend myself?
Well, as I said, it's always patches are a very big thing. In fact, the very first hacking class I ever took, it's kind of cool. I went to it. I'm going to keep in mind, I'm a network ops guy. So one of my students, I was teaching a Cisco class, shows me the book, Hacking Exposed. And now there's a whole bunch of these things. But when this first came out, it was really the first full disclosure thing I've ever heard of. You know, my gosh, I've never heard of this. So in 2001, they announced a class. And I'm, you know, again, I'm a network ops guy. I'm a little overwhelmed with all the security guys. The guys like, and then if they didn't have Service Pack 2, you'd be able to do this. And if you had this and they didn't have this Service Pack, you'd be able to do that. And I was like, guys, this is going to sound stupid, but are you telling me if I patched all my systems, none of this stuff works? He goes, well, yeah, but you know, a lot of people don't patch their stuff. I said, fine, I agree with you, I hear you, but I know where I'm going to put my attention. It's not learning the 50 million things I can do to you if you didn't patch. I need my traders to trade, my salespeople to sell. I just going to know where I'm putting my attention, patch management. So that's one of the best things you can do is patch management. Sometimes you can't. Sometimes you patch a server and it breaks it. So you try to restrict it. So maybe that server, that SQL server is vulnerable to a certain type of buffer overflow or whatever, but only the people in this one department use it. Maybe I could put an access control list at a firewall or something that prohibits them from getting access to it. And then the other thing you could do is, you know, security is about prevention, detection, and response. But I can't prevent everything. So if I can't prevent this from happening, I'm going to at least attune my IDSs to detect when it's happening and come up with a way to respond to it.
Excellent.
Cool.
Yeah, cool.
All
Thank
right,
you, Larry.
anything else?
Nope, that's it.
All right, thank you.
Now we hope you've enjoyed this free module, but there's lots more. The Cyber Kung Fu course has 29 videos in all and will really help build you a solid understanding of the CEH version 8 curriculum. Don't forget, if you prefer to attend one of Secure Ninja's courses in person at any of our training locations, you really need to visit secureninja.com/specials for some amazing discounts and other deals. I'm Alicia Webb. Happy training.
Secure Ninja TV is brought to you by SecureNinja.com, a world leader in cybersecurity training and certification. Our master instructors will help build you into a highly skilled and marketable security professional. Secure Ninja, forging cybersecurity experts.